When it comes to solving a limit question, we usually have the following methods: plug-in, factorization, L'Hopital's rule, and squeeze theorem. If we try to use the first method to plug in the point 0, 0 into the function, then we're gonna immediately get 0 over 0, which tells us that the first method does not work. And we can also see that the second method does not work either, because there's no common factor that you can find for the numerator and the denominator. Okay? And then the L'Hopital's rule does not work because it's only for functions with single variable. It does not work for functions with two variables of x and y like this. So that leaves us with the last option, which is to use the squeeze theorem. In order for us to use the squeeze theorem, we need to create two functions, one of which being the upper bound and the other being the lower bound. And we also require that these two functions approach the same limit as the point x and y approaches 0, 0. So before we construct these two functions, we do need to make an initial guess, that is what the limit of this function is. Otherwise, the functions, the bounds that we end up creating will just be some kind of random bounds, which does not work. Okay, so we're gonna observe that the numerator has degree 2 because it's product of x and y. Okay, and our denominator is equivalent to degree 1. That is because the square root can kind of cancel with the square here, so that is degree 1. So that tells us although the top and the bottom, both of which approach 0, the top is going to approach 0 much faster than the bottom. And that tells us that the limit of this function should be 0. Okay, so now let's try to think of two functions, upper bound and lower bound, both of which having 0 as their limit. The easiest function that we can think of as the lower bound is going to be the constant function 0, because obviously this function is greater than or equal to 0. Okay, so we're going to have this greater than or equal to 0. In order for us to create an upper bound, the way that we usually do is that we will construct a function out of this function by making either the numerator greater or making the denominator smaller. So let's say we try to make the denominator smaller to construct that bigger function. And then we're going to do some analysis here. Okay, we have this denominator underneath the square root being x squared plus y squared. We can drop one of the terms here to make the denominator smaller. So let's say we drop the term y squared. So that leaves us with x squared. And we have x squared plus y squared greater than x squared. Okay? And then we're going to take the square root on both sides, which leaves us with an inequality like that. So this kind of inequality still holds, right? And then we're going to take the reciprocal on both sides of this inequality. And that gives us 1 over x squared plus y squared is going to be less than or equal to 1 over this. Okay? And then since we have this one less than that, if we multiply absolute value of x and y on both sides of this inequality, then we should have this direction maintains the same. Okay, so we're gonna have by spare to erase the thing here. We're gonna multiply both sides by absolute value of x, y. Okay, so that leaves us with this. So one of the good things here is that we can simplify the right hand side, because that is essentially absolute value of x. And then for the top, we can write that as product of absolute value of x times absolute value of y. Okay, so this is absolute value of x. So now we can see that we can cancel this absolute value of x, absolute value of y, leaving us with only absolute value of y on the right hand side, which is going to be our upper bound function. Okay, and then we just said that previously that the lower bound function is 0. Okay, and we can check that as the point x and y approaches 0, 0, this function has 0 as its limit. This function also has 0 as its limit. So write that out, because limit x, y approaches 0, 0, constant function is going to be 0, and for the other function, absolute value of y is also 0. Okay. So by the squeeze theorem, we're going to have the limit of the original function which is xy divided by this, to be forced to go to the same limit, 0. Okay, so that is how we solve this question.